Greetings and welcome! Mr. Waddy here. We're talking about like circumference and arc length. The big idea about arc length is that basically this, whatever the measure of your arc is, all right, so if it's like arc AB and you want the length of it, you divide that by the total circumference, and that ratio should be the same as the degrees of the arc compared to the degrees in a circle, such as 360. Yeah, so that's the idea, is that these two ratios will be proportional to one another, and I'm then going to use this and plug in what I know and solve for what I don't. Side fact, circumference can be found a couple different ways. C is equal to 2 pi r. It's also equal to pi times diameter. So if I'm looking for circumference, I'll call it C. If I'm looking for the radius, or if I know the radius, I would use this version in the denominator. And if I'm using diameter, I would, or looking for diameter, I'd plug in this version of it. So you can have multiple representations of C there, depending on what suits ya. So here we go. If I'm looking for the measure of the arc DE, I currently know the arc length, so I'm going to say measure of D over the the degrees, because that's a degree, should equal the arc length, 8.73, over the circumference. Now here, 10 is what dimension? The radius, so I'm going to use this version of circumference, and I'm going to say 2 pi times tan. All right, so I could cross multiply, but I realize this is already in the numerator, so I'm just going to multiply both sides by 360. But you can really, once you have the proportions set up, you can solve any which way you'd like, as long as you obey the laws of mathematics. Here we go. So the measure of DE is approximately, and I'm going to do 8.73 multiplied by 360 divided by, and I might have to throw this in parentheses on my calculator. Let's see what I do. 8.73, typing numbers in is the most entertaining thing on the internet. Divided by 2, oh, there's a pi button now? Wow. 2 pi times 10 is the same as 20 pi, by the way. And I got about 50.02 degrees. All right? So that's the idea. Plug in what you know and solve for what you do not. And knowing the proportion is the thing that matters. Over here, notice I know the arc length. I know the angle measure. I'm looking for the radius. Which version of circumference has the radius in it? Yeah, the one in the middle. So I'm going to say 38.95 over 2 pi is going to equal 260 divided by 360. So let's see. Let's try cross multiplying this time. Multiplying, sure. 260 times 2 pi is going to be, what's that, 520 pi r? And 38.95 times 360, calculators, 14022. Yeah? And then I would do what? Just divide both sides by 520 pi, right? That feels weird. But I guess it could, yeah, because it's only 2 decimals, sure. So r is going to equal, I'll just divided by 520 pi. I got 84.71. I'm wrong? So wait, 14022 divided by 520 divided by pi. All right, yeah, I guess I didn't plug in. I needed parentheses on this last part there. That was my bad, friends. Thanks for helping me out, real life friends. My internet friends never point out when I'm wrong in real time. I hope someone tweets this video link to Robert Paterno. You can find him, internet friends. You got to make up for the fact that you're not helping me in real time. So let's see. Oh! Whoa! What is going on with this bike? What is that frame? Is that what it is? It's got no suspension. Fixed gear? Is that... Oh wait, there's a little bit of... Or those brake? No. Oh, it's disc brake? So it's fixed gear. Okay. So, it might have suspension there by the looks of it. But anyways, you ride your bicycle 40 meters. How many revolutions does the front wheel make? This is a circumference question. So question, what is the circumference of that? C is going to equal 2 pi times 32.5. C is going to be approximately, Isaiah, 2 pi times 32.5. And I get 204.20 centimeters. Now, this was 40 meters. What do I got to do? So I'm going to shift the decimal. C is about 2.04 meters. Oh, you wanted to convert. Oh, either way works. So this the circumference of that wheel is 2.04 meters. If I want to figure out revolutions, it's going to do 1 revolution each time this wheel makes 1 full turn. And I think I could figure that out by doing 40 divided by 2.04. Are you guys feeling that? Right, 40 meters divided by the distance it would travel with no slipping when that wheel revolutes. No. 40 divided by 2.04. And I get 19.6 revolutions. Maybe it was 40 meters downhill. Why? How many complete? Thank you. Man, Isaiah with the save, so the answer is 19. But that was, the last part was just a part of a revolution, so they didn't want rounded, they wanted complete. Okay, so ladies and gentlemen, let's keep going. All right, find the perimeter of the shaded region. Okay, perimeter. Shh. Ladies, gentlemen, quiet please. The perimeter of this figure is going to be 2 times these side lengths plus 2 times these little arc-de-loopties, right? So here's a little arc. I'm assuming those 2 arcs are congruent. Actually, those of you who got question 4 on the last test correct, are those 2 arcs congruent? Yes, because they have the same central angle measurement and have congruent radii. There we go. So these 2 segments are both 6. So the perimeter is just going to be 2 times 6 plus. Now how can I find this arc length? So you're going to say the arc length, let's just call that x. Well, there's multiple ways of thinking about it. But this isn't an area question, this is perimeter. Yeah. But today's problems will be area, so you're ready for them. So x compared to the circumference, 2 pi times 3. will equal 90 degrees over 360 degrees. All right? Let's just multiply both sides by 6 pi. And I will get x equals 90 over 360 is 1/4. So that's the same as 1/4 times 6 pi. And 1/4 and 6 I can cancel out by what number goes into both of those? 2. 2 goes into 4 twice and into 6 thrice. So I get x equals 3 pi. This length, because I wanted an exact value, not an approximation sometimes. I want you to know both ways. That is what I did. Ish. Right. Yeah, you could have viewed this as... Well, you're doing the same thing. I took 1/4 of the circumference and then doubled it. But yeah, you are right. You could have viewed that both of these make a full semicircle. So that's going to be half the circumference of one of those. Yep. That works. Let's see. Now, notice this. This arc, and this arc, 120, 120, 120, that's 360. My perimeter here is going to be 3/5 plus a regular circumference, plus 2 pi r. Right? 120 plus 120 plus 120 is 360. If I combined those, they would all form one full circle, right? Of perimeter. Am I getting an affirmative from anybody? Okay, all right. Now question, what is the radius of one of those circles? Now notice this distance between these two radii is 5, and therefore half of that distance is 2.5. So I could plug 2.5 in for r. Bowser. 15 plus 2 times pi times 2.5. I also could have done pi times diameter. P is going to equal 15 plus 5 pi. All right, I think that'll do it for now for our internet friends. Bye-bye.